Okay, here the recording in progress. So let me share the screen and get started. Okay, so our days are coming down to a very precious few. Not many days left at all. Okay. All right, so I will finish up the hyperbola. Okay, maybe sneak in one 6.7 problem, but that's pretty much about it. Okay, there are some questions that were asked for a previous section, so maybe we have time to do that, we will. Okay, so tomorrow is going to be our last regular quiz. I'll give you enough time to do the quiz, so we're probably not going to have a very long meeting tomorrow at all. I may just do one problem on the parametric equations and then stop so you can have more time to work on the quiz. Okay, so we just have parametric equations left, 6.7. I'll introduce the topic today, hopefully. Okay, so we will have the exam next Thursday, the 9th. Okay, so as usual, you turn in this homework. Okay, you must submit at least 70% of the homework. You know the rules by now. And then Friday the 10th will just be an office hour. You don't have to come if you don't want to. I'll just have the Zoom class as normal per se, but if you don't want to come, you don't have to. But if you want to come and ask questions, you may. In preparation for the final exam, my suggestion is maybe 2 a day. So Friday the 10th, review test 1 and 2. That's Saturday 3 and 4. And then Sunday 5 and 6. And then hopefully you'll be ready for the final exam. Okay, so 8:10 to 10:40, Monday the 13th. Same Zoom link. I'll make sure that the same Zoom link will work still. Okay, I do have office hours during finals week, I'm supposed to tell you, although again, it doesn't really make a whole lot of sense since it's over, but if you want to join, you may. I have to give you a different Zoom link for that if you wish. Okay, and so go back, you still have all the videos. The videos were sent out the day after the exams, right? So the solution video for the test 1 was on Saturday, September 4th, and then Saturday the 18th, right? So that would be my suggestion for, let's say, Friday after the test, so that would be Friday the 10th. Then maybe that Saturday, go back and review 3 and 4. So that would be what, Saturday, October 9th. Look back at that video. And then Saturday, November the 6th. And then Sunday, 5 and 6. So test 5 is the 20th of November. And well, you haven't had exam 6 yet, of course, but you'll get that video on Friday the 10th, it looks like. Okay, so review that for Sunday. And the final exam, most likely scenarios, I'll pick, say, 3 questions from every test. Okay, 3 times 6 is 18, and then maybe a couple more from somewhere else. So roughly 20 questions on the final. Notice you get 2.5 hours for the final. That's way more than an hour. So time should not be an issue, I'm guessing, for the final exam. Plenty of time to finish the final exam, and then we're done. Then you're done with the course. Okay. All right, but let's see, what else do I need to say? You don't have to submit any homework for the final exam. You know how you usually submit the homework for a test, but there's no more homework for the final exam. So don't submit any homework, just submit the final exam. You may have 6 formula sheets, 1 for each test. Okay, if you still have the formula sheet from the first test, second test, third test, fourth test, fifth test, just bring them all in. No need to reinvent the wheel. If you already have those 6 cheat sheets, just bring them in again. If you want to add to them, you may. Like you may have said, oh, I wish I had put this formula in. You can do that. So you can have 6 formula sheets for the final exam. How's that? Okay. The final exam will be similar in content to the previous exams. Okay. I'm not out to get you, so to speak. Okay. I don't go out of my way to say, oh, how can I make the test super hard so nobody passes? That's not my style. Okay. If you've been keeping up with the whole semester and doing what you have been supposed to do faithfully, you should be okay on the final exam. I'm not out to get you. Okay, but of course, if you haven't been studying and you haven't been practicing, then it might seem like I'm out to get you, but I'm not. You just maybe haven't studied, right? Okay, but if you give a fair college effort, so to speak, on all the previous exams, you should be okay in the final exam also. Okay, I'm not out to get you. I'm not out to mess you up, okay, or anything like that. Okay, I'm guessing you already know that because I give partial credit where I think it's warranted. I was a student before, so I know what it's like to be a student. So I try to be sympathetic to students in that respect whenever possible. Okay, so that is that. For next Thursday's tests, you're responsible for this. Right. And any other general questions before I get started? Okay, so our last regular quiz will be tomorrow. Okay, it'll be on the ellipse and the hyperbola. So I'll give you a couple of ellipse problems, a couple of hyperbola problems. Okay. All right, so back to hyperbolas. Okay, so problem 19. Focus at 2, 2, vertices 2, 1, and 2, -3. Anytime they give you something like this, go halfway between the vertices or halfway between the foci, whatever they give you. That'll be the center. Okay, so use that to figure out what's happening. All right, they only give me one focus, but they give me 2 vertices. So midway between 2, 1 and 2, -3 is 2, -1. You see, how do you know that? Well, you can get it from the graph or just average. Average the x's, still 2. Average the y's is -1. Right? To get an average, add them up and divide by 2. 1 plus a -3 is -2. Divide that by 2, it's -1. So there's a center. Double check. 2 up, you're at 2, 1. Go 2 down, you're at 2, -3. So these are vertices. That's my A. Now they tell me that a focus is at 2, 2. That's up here. That is 1, 2, 3 units away from the center. So C is 3. So there's our old friend that our author seems to be putting a lot. B is going to be radical 5. Okay, A squared plus B squared equals C squared. Okay, so I figured out A is 2. What's my A? Distance from center to either vertex. Little c is distance from the center to a focus. Okay, there's a focus here, but I don't really need it. I didn't bother to draw this accurately because it just asks for the equation. So C is 3. A squared plus B squared equals C squared. So 4 goes here, 2 squared. 9 goes here, 3 squared. Subtract B squared is 5. B is radical 5. The hyperbola is going up and down. So automatically, I know it's y coming first. And the center I figured out was 2, -1. So it's y minus a -1 squared over something minus x minus 2 squared over something equals 1. And now I know this is a squared. 4 minus b squared. 5. That's all there is to it. So here's the equation of this hyperbola. Yes, I didn't bother with the box and the diagonals. You don't really need it in this case. Okay, so it only asks for the equation of the hyperbola. So they ask for the equation of hyperbola. Here it is, and I'm finished. Okay. All right, so that's it for that one. 23. Vertices are 0 plus or minus 2, passing through 3, 4. Vertices 0 plus or minus 2, 0, 2, 0, -2. All right, that tells me it's a vertical hyperbola centered at the origin. How do I know it's centered at the origin? It's halfway between 0, 2 and 0, -2. That's our best case scenario. So once again, it's y squared over something minus x squared over something equals 1. Furthermore, I know that a is 2. So this is automatically going to be 4. Okay, how do I go on from there? I know it passes through the point 3, 4. So I have y squared over 4 minus x squared over b squared equals 1. 3 here, 4 here means I can figure out the b. Okay, so put a 3 here, put a 4 here. 4 squared over 4 minus 3 squared over b squared equals 1. Okay, now 4 squared over 4, that's 16 divided by 4, that's 4. Subtract 4 on both sides. Negative 9 over b squared equals negative 3. Multiply both sides by negative 1. 9 over b squared is 3. Multiply by b squared. 9 equals 3b squared. Divide by 3. B squared is 3. So b is radical 3. But ultimately, you want b squared. Okay, b squared goes underneath. B squared is 3. So I put the 3 here and I'm done. So y squared over 4 minus x squared over 3 equals 1. Okay, and that's it for that one. Okay. All right, then 25. And then 25, I would just about be done with the hyperbola. Okay, which means I can knock this off. Okay, so I'll introduce 6.7. Okay, but not get that far. And then there were a couple of questions in the chat. I'll go back and take a look at those. And then that's it. We're probably going to be done fairly early today. And tomorrow, I definitely want to finish somewhat early so you have time to work on the quiz. Okay, so 25. 25 vertices, plus or minus 3, 0. Again, that tells me I'm centered at the origin. Best case scenario, right? So how do you know it's centered at the origin? What's halfway between negative 3, 0 and 3, 0? 0, 0, the origin. And then the equation of the asymptotes y is plus or minus 4/3 x. Okay. So how do I do that? So vertex plus or minus 3, 0, negative 3, 0, 3, 0. What's halfway? Origin. Okay. These are two vertices, so it's curving left and right. So x comes first, centered at the origin. So automatically it's x squared over something minus y squared over something equals 1. Okay, now, got a vertex at 3, 0, negative 3, 0. That tells me the a is 3. A is 3, which means a squared is 9. So 9 goes into here. And then the asymptotes are y equals plus or minus 4/3 x. Okay, well, I already know I'm going over 3. So rise over the run is 4/3, right? So 1, 2, 3, 1, 2, 3, 4, which means my box would go like this. Okay, so it's over 3, up 4. I got to go over 3 anyway. So if I go up 4, I'm here. So this is y equals 4/3 x. This is y equals negative 4/3 x. And so that tells me the b is 4. Right, so if b is 4, b squared is 16. That does it. So my equation is x squared over 9 minus y squared over 16 equals 1. Okay. All right, and that is it for the hyperbola, folks. So I think I've given you everything you need for the hyperbola. I can mark that off. Okay, we're down to our last section, believe it or not, folks, in pre-calc 6.7, something called parametric equations. Okay. I don't really have to start today, but I'll do what I normally like to do. If I'm a little bit ahead, I'll go ahead a little bit and still finish somewhat early. So what's parametric equations all about? 6.7. Okay. So let me just introduce that concept, maybe do one problem, and then there were some questions in the chat that I want to get. Okay, we're skipping 6.5, which is on polar coordinates. We're skipping 6.6, more polar coordinates. 6.7, parametric equations, page 360. Okay, what's parametric equations all about? Okay, suppose you have x as a function of t and y is also a function of t. Okay, t is called a parameter. It's another variable. Okay, so t is going to be involved in x and also y. So are x and y related? Well, yes, because they're both related to t. Okay, so here's an example of what parametric equations might look like. X is a function of t, 2t plus 1. Y is 4t squared minus 1, t between -1 and 1. Okay, so are x and y related? Yes, because they're both related to t, also sometimes called the parameter. Now, in some of the homework problems, they'll ask us to eliminate the t, eliminate the parameter. Sometimes you can do it, sometimes you can't. So look at what they did. They made a chart. Said t goes from -1 to 1. By the way, sometimes they're not even going to give you that. So they made a little table. Okay. You can take these t values, plug in here. Take these same t values, plug in here, and then forget about this, and then just plot x and y the usual way. Although t can be thought of as the passage of time. Okay, so I'll plot 1, -1, 2, 0, 3, 3, 0, 0, -1, 3. Okay, so you plot here, x is equal to 2t plus 1, right? So you give me a value for t, you figure out the x all the way down. Then based on this, you plot t versus y. Okay, when t is 0, y is -1. When t is a half, y is 0. When t is 1, y is 3, and so on. Then I just simply plot x versus y the usual way and forget about t, although t can be thought of as the passage of time. So at time t equals -1, yeah, it's a little bit weird for time to be negative, but it's allowed. Usually we want positive times, but it's allowed. And the arrow indicates a passage of time as time goes by. When t is -1 second, I'm here. T equals 0, I'm here. T equals 1, I'm here, and so on. And to end it with a shape like that. Okay, so that's the basic idea behind parametric equations. Let me show you the problems. Okay, so we only have to do what? 1 to 19 odd? 6.7, 1 to 19 odd? So here we are. For those of you who don't have the book and aren't getting it, page 364. All right, so it says find a corresponding rectangular equation, sketch the graph of the curve described by the parametric equation showing it possible when t is 0 and the direction of increasing values of t. Okay, so if possible, eliminate the parameter t. And some more there. Yeah. 17 and 19. That's it. Okay, so I was just going to show you one problem, just so you get a feel of it. I have more time tomorrow and Monday and Tuesday to knock it off. Okay, so x, y, x, y, x, y. Okay, how are x and y related? Well, they're both related to t. Okay, so I'll show you how one of them goes. And that was going to be it for today. Okay, number one, x is 3t, y is t over 2. Now, they don't tell me what t values to go from, so I can make up my own. I decided to go from -4 to 4, counting by 2s. I saw it was t over 2. I didn't feel like plugging in odd numbers, but plugging in even numbers is pretty nice, right? Okay, so I decided to go from -4, -2, 0 to 4. Why? Well, it has 0, it has positives, it has negatives, and I didn't want any fractions, so I plugged in only even numbers. This one doesn't matter. Okay, plug in -4, -12. Plug in -2, -6. 0, 0, 2, 6, 4, 12. Right? And then do the same thing, t versus y. T divided by 2. That's why I decided to pick even numbers. -4 divided by 2, -2. -2 divided by 2, -1. 0 divided by 2, 0. 2 divided by 2 is 1. 4 divided by 2 is 2. And now when I plot, I do the usual plot of x versus y. Negative 12, 2, negative 2, negative 6, negative 1, 0, 0, 6, 1, 12, 2. And this can be thought of as the passage of time. Okay, so this is t equals negative 2, t equals negative 1, 0, 1, and 2. So as time increases, we're going this way. It looks like a straight line. Can I prove it's a straight line? Yes, that's by eliminating the parameter. In other words, can I get my usual x versus y and forget about the t? Sometimes you can't. Sometimes it's so messy that you cannot. But for the ones that we're doing here, you pretty much can. So first I will solve for t here. How do I isolate the t? Divide by 3. T is x over 3. Now you pick this up and plug it in here. That eliminates the parameter t. Parameter is another variable. Okay, your basic variables are x and y. T is the parameter variable, as it's called. Okay, so can I get rid of t? Yeah, just put x over 3 here. X over 3 divided by 2. Recall from algebra, you're allowed to slide that 3 down with the 2. 3 times 2 is 6. So y equals x over 6, or 1/6 x. And yes, I do recognize that as a line with a slope of 1/6 and a y-intercept of 0. And that does seem to jive with what I have over here. So y equals 1/6 x seems to be the solution. Okay, so that's what we're up against for these parametric equations. I've shown you just one problem. We'll do many more tomorrow and next week to do the rest of it. But I'm going to stop there. And we had a request for some previous problems, I think parabolas. Okay, so let me go back and do those. Okay. I'll have to stop the share temporarily. Chat. Okay, I had a request for 6.2, 33, and 35. 6.2, 33, and 35. Okay, so let me go back in and see if we can do that. 6.2, 33, and 35. Oh, yeah, those are problems that we were going to skip anyway. So I think I'd rather not do those. They're interesting problems, but it'll lead me to.
That's what I thought. I just didn't remember.
Yeah, it leads
Thank
me
you,
to a path that I don't want to go down.
Okay.
So, yeah, so let's skip those problems. Okay. All right, so based on that, I don't have to do those anymore. Otherwise, that was all I was going to cover today, folks. Anybody else have a question? Otherwise, maybe I'll just sneak in one more of these parametric equations.
Could I actually look at it was one of the ones you just did was 6, 4. Let me get back to it. Your problems for 23, 6, 4, 23, your work.
Okay, 6.423.
Yeah, can I just see your work one more time?
Let me see if I can find it here. 6.423. Okay, so this information tells me I'm centered at the origin. It's going up and down. That means y comes first. I'm centered at the origin. Y squared over something minus x squared over something equals 1. I know that a is 2. That makes this 4. And then to find the b, I plug in 3 and 4. So 3 goes here, 4 goes here. 3 comma 4. So 4 squared over 4 minus 3 squared over b squared equals 1. And finish up the algebra. So that's 16 divided by 4, which is 4. Subtract 4 on both sides. So negative 9 over b squared is negative 3. Multiply by negative 1. 9 over b squared equals 3. Multiply both sides by b squared. And divide by 3. So b squared equals 3, or b equals radical 3. So that gives me y squared over 4 minus x squared over 3 equals 1. And that's pretty much about it. Yeah. Okay, anybody else with a question? Otherwise, we can quit. So tomorrow, give you a quiz. I'll do maybe one more of the parametric equations, but I'm going to leave you plenty of time to work on the quiz also for tomorrow. Okay, so any other questions? Let me check the chat. I'll have to stop the share for that. Okay, I don't see anything else in the chat. Okay, so any other questions, please? Wait just a moment. All right, hearing nothing and seeing nothing, that'll do it for today, folks. All right, so I'll continue tomorrow and quiz tomorrow, and we'll see you next time. Okay, all right, bye, everybody.
Thank you.
Thank you.
Bye.
Okay,
Thank you.
Bye.